class now by reviewing these two problems. I don't see anybody sent me any answers on the chat. I would have liked to give some extra credit to people who did that, but let's do these together then. Oh, okay, Ariana. You gave me CMB. Let's see. First of all, let me write down your extra credit. Getting 2 because you gave me answers for 2. Okay, so let's look at this number 1, where it says to simplify square root of 50 plus 3 times the square root of 128 plus 4 times the square root of 162. And remember, we said when we're adding radicals, we can only add like radicals. So we have to simplify each of the radicals. So the first thing we're going to do is we're going to take this square root of 50. I'm going to do everything over here. And I think, what can 50 be broken up into? And obviously the answer is 25 and 2, because 25 is a perfect square. And the square root of 25 is going to give us 5. So this first thing, the square root of 50 is going to be simplified to 5 radical 2. The next thing we have is 3 times the square root of 128. Now, remember, this is a multiple choice problem. If you notice, all the choices end with a square root of 2. So it seems to me that I'm going to try dividing the 128 by 2 and see what happens. And if you divide 128 by 2, you get 64. In other words, we can break up the 128 into 64 and 2. And then the square root of 64 we know is a perfect square. So we can now multiply. That becomes 8 radical 2. But since there was this 3 outside in the beginning, remember, we're going to multiply these two together. There's no sign in between these two, which means the operation is multiplication. So this is going to become 3 times 8, 24 radical 2. The last thing we have is 4 times the square root of 162. And going along with the fact that everything should be a square root of 2, I'm going to divide the 162 by 2. In other words, let the answers on a multiple choice guide you if you can. This will, if you divide 162 by 2, you get 81, which is a perfect square. So you can break the 81 down to 9 radical 2. And don't forget, you have this 4 from before that you have to multiply. So that'll give you 36 radical 2. So what we have here is 5 radical 2 plus 24 radical 2 plus 36 radical 2. And remember that when you're combining, which means adding or subtracting of radicals, once you have the same radical, you just combine the numbers in front, the coefficients. So 5 and 24 is 29. 29 and 36 is 65. So we're getting 65 radical 2, which is choice C. You might have noticed also, if you were really looking at the answers, all of the other 3 answers were negative. But in my original problem, everything said plus. So if I were in a rush or I really didn't know what to do, I could have realized the only answer that would make sense in this multiple choice would be a positive answer, and I could have picked C and had a very good chance of getting that correct. Okay, so that's question number 1. Question number 2 says rationalize the denominator. And if you recall what we said about fractions, what we're always looking for is to make sure that we don't have any square roots left in the denominator. Even if it just said simplify, the big thing is that radical in the denominator. Now, nothing else can be simplified because the 3 and the 4 are outside the radical. So they're as simple as you can get. And the radical 3, you can't break it down any further. Well, if you recall what we said, when you have a binomial, which you recognize because there'll either be a plus or a minus between the two terms. So to rationalize the denominator, you have to multiply by what we call the conjugate of the binomial. The conjugate binomial is the one that looks exactly like it with the opposite sign. So the conjugate of 4 minus radical 3 is 4 plus radical 3. Remember, and it's always, even if you have a radical on top and on the bottom, when you want to rationalize the denominator, you want to go to the conjugate of the denominator of the bottom. Now, of course, whatever you're going to multiply the denominator by, you're going to have to do the same thing to the numerator. And erase this. I have a little bit of room here. So let's first deal with the denominator. We want to multiply the 4 minus the radical 3 times the 4 plus radical 3. And as I said, these are conjugates. Conjugate binomials, when you multiply them, you do not have to do the whole FOIL. You can get away with just doing first and last because the outer and the inner for sure are going to cancel out when they're conjugates. And we're specifically multiplying them. Question? We're specifically multiplying by conjugates, so I'm going to do just first times last. First times first and last times last. 4 times 4 will give me 16. Minus times plus will give me minus. And radical 3 times radical 3. Remember, when you're multiplying a radical by itself, you get the number outside the radicals. So square root of 3 times square root of 3 is just 3. And this is just 16 minus 3, which is no radicals, just the number 13. When you multiply by a conjugate, you get rid of the radicals. Well, we've taken care of the denominator. The denominator is going to be 13, so obviously it's going to be either choice C or choice D. So let's see what happens when we multiply the numerators. This is 3 times 4 plus radical 3. I'm multiplying a single term, 3, by a binomial. And we know we have to use the distributive property. So we have to do 3 times 4 is 12. And 3 times radical 3 is 3 radical 3. So my final answer becomes 12 plus 3 radical 3 over 13, which happens to be choice C. Okay, so C was certainly correct for the first one. C was also correct for the second one. Remember, you have to, you have to multiply by the conjugate. Okay. Let's go on from here. We'll keep reviewing. Those of you who noticed, I see a couple of people already did. There is quiz number 3 was posted on Delta Math, and I will probably be posting for Friday, for over the weekend, new homework on Delta Math. I don't want to overburden you. I would like to see you finish up the homework on Chapter 5 and go on to the quiz on Chapter 5 on Delta Math. That is what you're required to do through until Friday. Again, there will be a new set of assignments on Chapter 6 being over the weekend. And I did see that a few people had already done that quiz, so that's good. Excuse me. Hi, Jenny. Oh, yeah, I texted her, she said, okay. Until about 12, till 12. Okay, or probably a quarter to 12, probably more likely. Yeah. Okay, I'm in the middle of teaching. Bye. Okay, so going on from what we did the other day, what we're going to talk about now is how do we solve equations that have radicals in them. So I'm going to start with a very easy one. And if you'll see how the easy one is done, you'll get an idea of how to go on with more complicated ones. What if I gave you this equation? The square root of x is equal to 9. And I ask you, I want you to figure out what x is. So don't make the mistake of saying, oh, it should be 3. Because what we're doing here is we have a number that we're starting out with, which we don't know what it is. We're taking its square root, and the answer we're getting is 9. I think if you really think about it, you'll see that x would have to be equal to 81. Because if you take the square root of 81, you're going to get 9. So let's think what we actually did. We wanted to get rid of the radical. The radical says take the square root. Now, whenever we're solving equations, our first step is to try and do the opposite of what's going on. In other words, if I have x plus 3, I do the opposite of the plus 3 and I subtract 3. If I have 3x, in other words, if I have my x multiplied by 3, I do the opposite of operation, what we call the inverse operation, and we divide by 3. So that's the same thing here is. We have the square root of x. We're taking the square root, so we want to do the opposite operation. What's the opposite operation of taking the square root? It's obviously squaring it. The square root, you're finding the number that we multiply by itself to get that number. So the opposite operation is to actually multiply the number by itself. And that gives us a very good method of solving radical equations. We're going to get our radical. Once we have our radical by itself, we're going to multiply it, we're going to square it, and that will give us the number that's inside the radical without the radical sign. So if I were to give you something like this, the square root of 3x plus 4 equals, I'm sorry, 3x plus 4 equals 5. Again, this is a radical equation. I want to get rid of the radical. Now, the first thing, just to remember when we did absolute value equations, the first thing we always did was make sure we got the absolute value by itself, nothing else. Same thing over here. We're always going to isolate our radical. We only want to have a radical by itself. Well, that's what we have. There might be a bunch of things inside the radical, but the radical itself is all by itself. Once I have that, then I'm going to want to get rid of the radical by squaring both sides. Remember, when I square or multiply the square root of 3x plus 4 times the square root of 3x plus 4. In other words, when I multiply this by itself, I just get the 3x plus 4. Because multiplying a radical by itself basically gets rid of the root, moves the radical, gets rid of the radical, and you're left with what's inside. On the other side, I have a 5. It's not in a radical. So therefore, when I do 5 squared, I actually have to multiply 5 times 5 and get 25. So look what happens. The side that looks much more complicated, the one with this whole square root business, is really the easier side to deal with, because all you're doing is basically taking an eraser and erasing the radical. But the side that doesn't have a radical, I actually have to do the work of multiplying it by itself, of squaring it. Of course, now I have just a regular equation. I'm going to subtract 4 from both sides. That'll give me 3x equals 21. And I'll divide both sides by 3, and that'll give me 7. My answer in this equation is 7. Now, I don't know if you remember, we just did in rational equations that had fractions on them. We really had to make sure that we checked our answer, because sometimes the answer made the denominator equal to 0. And you can't have the denominator equal to 0. So therefore, you have to check your answer to make sure your denominator is not turning equal to 0. In other words, it's not giving you what we call an extraneous root. With square root or radical equations, we have the same problem. We have to make sure that we don't have an extraneous root. So radical equations always must be checked. Most of the time, the answers will be good. Just we'll see, there'll be times where the answer is not correct. So let's check this. We're going to do 3 times 7, because my x I told you is coming out to be 7, plus 4 should give us 5. Well, the first thing we have to do is do 3 times 7, which is 21. Plus 4, that's 25. Is the square root of 25 5? Yes, it is. So this answer 7 is a good answer to this equation. We have solved this radical equation by getting x equal to 7. Okay, let's try another example. I'm going to do 2 more for you, and then I'm going to give you some to try. Okay, suppose I have the square root of 5x minus 1 plus 3 equals 7. Now, if we notice, we have a radical on this equation, but the radical is not by itself on this side. there's something outside the radical. I don't care about this, but there's a number 3 that's not. Now be careful when you write these things that you don't make this line go too long and it looks like the 3 is in the radical. The 3 is not in the radical. The first thing I have to do is isolate that radical. I have to get that radical by itself. So I'm going to take the 3 and subtract it from both sides, which will give me the square root of 5x minus 1 equals 7 minus 3, which is 4. And now at that point where I was before, where I have my radical all by itself, I want to get rid of the radical. I'll do that by squaring both sides. The side that has the radical just gets me what's inside the radical without that sign. The other side that's not inside a radical sign, I actually multiply it out. 4 times 4 is 16. And then I'm going to bring 1 to the other side to get this is a regular equation now. 5x equals 17. And divide by 5. And my answer comes out to be 17 over 5. If you wanted to, you could also write it, you could leave it like this. This is a perfectly good answer. Or you could change it to decimal form, which is 3.4, and that's also a perfectly correct answer. Again, we want to check the answer. So we're going to do the square root of 5 times 17 over 5 minus 1 plus 3 on the other side equals 7. Go back to the original equation. Okay, so I have to, and you could definitely do this on your calculator. You have to do 5 times 17. Well, you could see that this 5 on top cancels with the 5 on the bottom. Or if you want to, you could actually multiply 5 times 17 and get 85 and then divide it by 17. So that's giving you 17 minus 1, which is the square root of 16, which we know is 4. So this part becomes 4. 4 plus 3 equals 7, and it checks. Because 4 plus 3 does equal 7. Okay. Gonna do one more, and then I'm gonna give you one to try, and then we'll try some that are a little bit harder. Suppose I gave you this example. Square root of 4a plus 1 plus 3 equals 2. Okay. Again, I see I have a radical equation. Again, I'm going to square both sides. But before I square both sides, I first have to isolate the radical. I have to get rid of this plus 3. So I'm going to minus 3 from both sides. That's going to be my first step. Get the radical all by itself. So we have the radical of 4a plus 1 equals 2 minus 3, which is -1. Okay, the next thing I'm going to do is I'm going to square both sides. When I square this side, I'm going to get 4a plus 1. I get what's inside the radical without that radical sign. When I square the other side, when I multiply the other side by itself, I actually have to do it because there's no square root there. -1 times 1 gives me 1. Okay. Now we can finish this. I'm going to subtract 1 from both sides. That'll give me 4a equals 0. And if I divide both sides by 4, 0 divided by 4 is 0. Now, 0 is a good answer. Don't think that because the answer is 0 that you have to throw it out. But what we must do is go back to our original equation and try and check. So here's our check. In place of a, we're putting 0. So we're doing 4 times 0 plus 1 plus 3 equals 2. Now we know 4 times 0 is 0, and 0 plus 1 is just 1. So we're getting the square root of 1. And of course, the square root of 1 is just 1, because 1 times 1 is 1. So this becomes 1 plus 3 equals 2. And I end up with 4 equals 2, which is obviously not right. This is not a correct solution. There's no solution here. Remember, sometimes we use this symbol, the 0 with a slash through it. That's a way of saying no solution. Let's see why. In other words, I did all the correct work. Everything I did here was correct. And yet I got an answer that doesn't work. I got an extraneous root. Let's go back and see where the problem arose. Over here, I had the square root of 4a plus 1 plus 3 equals 2. And I subtracted 3 from both sides so that I ended up with the square root of 4 plus 1 equals -1. And I should have been able to tell right there that that can't work. Why? Because by definition, the square root of a number is always positive. In other words, if I ask you what's the square root of 25, you're not going to say it's -5. Your answer is +5. That's one of the things we spoke about at the very beginning when we started talking about radicals. When you have a radical, the square root of 36 has to be +6, even though -6 times -6 would also give you 36. When we use that radical symbol, that specifically means what we call the principal square root, which means the +1. So therefore, if I ever get an expression where I have the square root of something equaling a negative number, we can stop right there. And that should remind you what happened when we had absolute values. Remember, when we got the absolute value, the first thing we did is we looked. Does it equal a negative number? Stop there. It's impossible. There's no solution. But if it equals a positive number, you can go further. The same thing occurs when you have square root of negative square roots. If you have a square root equaling a negative number, stop right there. That problem cannot be solved. There's no solution. There are other instances where you get extraneous roots, but specifically, if you see something like this, you don't have to go any further. Don't go to doing all the work, because then you're going to say the answer is 0, and the answer is not 0. The answer is no solution. 0 would have been a solution. This has no solution. Okay. So that being the case, I'm going to give you a couple of examples to try. Okay, here's number one. See if you can solve this. The square root of 2x minus 3 plus 4 equals 7. And this one is going to be a multiple choice one. So this is a freestanding one, open. But this one's a multiple choice. Here are your choices. Okay. Give me a few minutes to do that. David? 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 Is Carmen here? No. Hello? Where is Carmen even come here yet? Oh, okay. Okay. All right. I'll put, okay, bye-bye. David, leave the door open. Yeah. All right. Okay, let's work on these two problems and see what we get. I see for number one, I see you came up with 6. And let's see. Let's see if we come up with both, and I see Kayla also came up with 6. Let's see if that is the correct answer. Let me first give you some extra credit. So the first thing we're going to want to do is get rid of this 4, so we have the radical by itself. So I'm going to minus 4 from both sides, which will give us the square root of 2x minus 3 equaling, well, 7 minus 4 is 3. And now we're going to square both sides to get rid of the radical. This side will become 2x minus 3. And this side will do 3 squared, which is 3 times 3, and get 9. I'll then bring this 3 to the other side, because now we have just a regular equation. We have 2x equaling 12. And dividing by 2, we get x equal to 6. Just let's make sure it checks. Replacing, so we're going to have 2 times 6 minus 3 plus 4 equaling 7. And 2 times 6 is 12. 12 minus 3 is 9. So we have the square root of 9 plus 4 equals 7. Of course, the square root of 9 is 3. So 3 plus 4 equals 7. 6 is the correct answer. Perfect. Okay. And let's see about, I see Isis, he gave me an answer to the second one as well. So let's see if that one works. Let's work on the second one. So Isis is telling me that she thinks the correct answer for number 2 is A. Now, truthfully, you have a bunch of answers here. What you could do is just try substituting the answers and seeing which one works, because that's basically what you're doing when you're checking. But let's just do this the regular way. Let's add 3 to both sides. And we'll get the square root of x plus 1 equaling 8. And now we'll square both sides. That'll give me the square root of x plus 1 equals 8 times 8, which is 64. I'm sorry, not in the square root. No longer in the square root when I multiply it by itself. Sorry. When I square the square root of x plus 1, I just get the x plus 1. 8 times 8 is 64. And now to get x alone, I'm just going to bring the 1 to the other side, and it does give me x equals 63. Just checking it, the square 63 plus 1 is 64. The square root of 64 is 8. 8 minus 3 is 5. 8 is the correct answer. Thank you. So that, just let's try one that's a little bit harder to do. And we'll come up with, I'll do one like that. We don't see it too often. These more complicated ones, you don't see too often on the math final, but occasionally it does come up. So let's see if we can do one of the more complicated ones. So let's say I gave you an example that looks like this. Suppose I gave you that x equals the square root of x plus 7 minus 5. And we're going to do the same thing we've been doing as we before. In order to solve this radical equation, we want to get the radical part all by itself, which means I have to get rid of this 5, this minus 5. So I'm going to add 5 to both sides, just like I did before. So what's going to happen? Over here, I'm going to get x plus 5. I can't combine them because they're not like terms. One has an x, one doesn't. Of course, on this side, we're just left with the square root of x plus 7. Well, if we follow the pattern that we did before, once we have our radical by itself, we're going to square both sides. I'm going to do this side first because that's really easier. The side that has the radical, when you square it, just gives you what's inside the radical without that radical sign. Square root of something times itself just gives you what that something is. So that we know from before. On this side, I have to do x plus 5 squared. Now notice I wrote this out because I can't just do the x squared and the 5 squared. This is a whole unit, x plus 5. I have to do x plus 5 times itself. In other words, I have to multiply the binomial x plus 5 by itself using FOIL because it's a binomial times a binomial. And doing that, I'll do x times x, which will give me x squared. Outer will give me 5x. Inner will also give me 5x. That always happens when you're squaring the binomial. You get the inner and the outer are always the same. I could have just done it this way. X times 5 would be 5x and 5x. And last is 25. In other words, this is x squared plus 10x plus 25. That we get from squaring x plus 5 squared. That equals the x plus 7. And now you'll see why I said this is much more complicated. Because the type of equation we're getting is a quadratic equation. We're getting an equation that has an x squared. If you notice, we keep building. Each chapter is used in the next chapter. We learned how to solve a quadratic equation. We learned that when we have a quadratic equation, we have to get it equal to 0. So I'm going to have to minus x from both sides and minus 7 from both sides. So then I'll end up with a quadratic equation x squared. 10x minus x is 9x. 25 minus 7 is 18. And this equals 0. Okay, I'm going over here because obviously this is much more work involved than we had before. So we have this quadratic equation x squared plus 9x plus 18 equal to 0. And what we know is that when we have a quadratic equation, we're going to try and break it up into 2 parentheses. So what are the 2 parentheses? First of all, I don't have to do this AC business because I'm starting out with just a plain x squared. So I'm going to break up the x squared into x and x. Then remember, I go to the last term, which is 18, and I'm looking for, this is positive. So I'm looking for 2 numbers that are going to multiply to 18 and add to 9. And it's going to be 6 and 3, because 6 times 3 is 18, and 6 plus 3 is 9. And since this, remember, both signs are going to be the same, the middle sign is plus, so they're both going to be pluses. And then we're going to take each one separately, and we're going to do x plus 6 equals 0, and x plus 3 equals 0. So one answer is going to be -6. And one answer is going to be -3. So my two answers are x equals -6 and x equals -3. What must I do now? I have to check those answers. I must check. Very often when you get two answers, one will be good, one will be not good. We have to see if we have an extraneous root. So first checking with the -6. I'm going to get -6 plus the square root of -6 plus 7 minus 5. I'm sorry, this is not plus, this is equal. -6 equals the square root of -6 plus 7 minus 5. I'm just replacing in my original equation the x with -6. So this is -6. This -6 plus 7 is 1. So this is the square root of 1 minus 5. Now the square root of 1 we know is just 1. 1 times 1 is 1. So I'm getting -6 equals 1 minus 5. And -6 equals -4. Well, obviously that is false. This answer is an extraneous root. It's no good. I now have to check my second answer. So well, let me find a place where to check the second answer. I'm going to go right over here. Let's see if I can check the second answer over here. Here's x equals -3. Don't forget to give yourself a lot of paper. If you notice, it's got a lot of work. So this is going to be -3 equals the square root of -3 plus 7 minus 5. So -3 equals, well, the square root of -3 plus 4 is the square root of -3 plus 7 is the square root of 4 minus 5. And the square root of 4 we know is just 2. So I get -3 equals 2 minus 5. And that does check. So this answer is a good answer. The only answer to this equation is -3. There are not two answers, there's only one. When you get a question like this, it might be neither answer works, it might be both answers work, it might be one answer works and one doesn't, as in this case. Notice we did all the correct work, but there we got what's called an extraneous root. We got, by doing the correct work, we got a false answer. We always can pick it up as long as we are checking. Okay, I'm going to give you a question that's off a final and see if you could do this one. Again, this is going to be a multiple choice question. Can I erase this now? Anybody still need time to copy? If not, I'm going to erase it now and put in the new question. The question is x equals the square root of x plus 13 plus 7. And here are your choices of answers. 3 and 12. 3, 12, and -9. Okay, so you have A, B, C, or D. Let's see if you could come up with the answers. While you're doing that, I'm going to be taking attendance. Olivia, Isis. I know you're here because you sent me an answer. Good morning. Elvira, Lewis, Lewis Hart, Emma.
I'm here. Good morning.
Good morning. Demetrius, Desmond, Shania, Kayla, I know you're here. Sanjita, Ariana, I know you're here. Tahira, I know you're here. Michaela, Kiana, I know you're here. Carly, if I see you're here. Ruth Jenna.
Yeah,
Hi.
hello.
Tatiana. Naya. Naya here. Kazandu. Trina. Jean. Okay. Anybody willing to venture a guess as to which is the correct answer? A, B, C, or D? Yeah, I did. I saw you. Tahira, I saw you. Carly, if you think it's choice C. Okay, let me give Carly a check for extra credit. And let's see. If that's the correct answer. I see Isis is also saying it's C. So that looks like probably a pretty good catch. Some of you people have a lot of extra credits. They're going to help you when it comes to your final grade, because again, if you're, let's say, running a 75 average and you have a lot of extra credits, it'll probably boost you up to a B rather than just a C. So those extra credits do help. Okay, I'm going to do this a short way, and then I'm going to do it the right way. Short way. It's a multiple choice question, which means I only have a certain number of answers that could possibly work. If I look at the answers they're giving me, one answer is 3 and 12, one answer is 3, one answer is 12, and one answer is -9. So really, they're not even giving me 4 different answers. They're only giving me 3 different answers, because they're giving me 3, 12, and -9. Guess what I'm going to do? I'm going to try the answers. And basically what I'm doing is just to check without the original work. So here's what I'm going to do. The first answer they're giving me is 3 and 12. So I'm first going to check with x equal to 3 and see if that works. So it's going to be, okay. 3 equals the square root of 3 plus 13 plus 7. Well, let's see. This is 3. This 3 plus 13 is 16. So this is the square root of 16 plus 7. We know the square root of 16 is 4. So this is giving me 3 equals 4 plus 7, which is 11, which is obviously wrong. 3 is not a correct answer, which means I can automatically cancel out choice A, because that said 3 and 12 were both correct, and 3 is obviously not correct. And I also can cancel out choice B, because that's choice x equals 3. So now let's go to C. Let's check with x equal to 12. If x doesn't equal 12, I can automatically just pick -9, because that's the only other choice that works. So let's check with 12. 12 equaling the square root of 12 plus 13 plus 7. So this says 12. The square root of 12 plus 13 is the square root of 25. And we know what the square root of 25 is. It's 5. And 5 plus 7, that's 12. This does work. So here is our correct answer. I don't have to go any further. C was the correct answer. And I didn't have to do all the long work that I did before. Basically, all I did was the check. Just to show you how you would do this on an open-ended question, let's go back to the question. Okay, remember, this is a radical equation. We want to get the radical by itself. So I'm going to have to subtract 7 from both sides. You're going to see how much work this involves. So this will give me x minus 7, because I can't combine them, they're not like terms, equaling the square root of x plus 13. And now to get, since I have the radical by itself, I'm going to square both sides to get this rid of the radical. So on the side that doesn't have the radical, the side that looks simpler when you look at it actually involves a lot more work, because I have to actually multiply the x minus 7 by the x minus 7. And I have to do it as FOIL because it's a binomial times a binomial. The other side is simpler, because when you have a square root and you're squaring it, all you get is what's inside the square root. So squaring this radical business just gives me x plus 13. Now I've got to multiply this out. And I have to do FOIL. X times x is x squared. Outer is negative 7x, and inner is also negative 7x. Negative 7 times negative 7 is 49. Which gives me x squared minus 14x plus 49 equals x plus 13. And since it's a quadratic equation, I'm going to have to get it equal to 0. So I'm going to minus x from both sides. And we're going to minus 13 from both sides so that we can get it equal to 0. So this is going to give me x squared. Negative 14x and negative x is negative 15x. 49 minus 13 is 36. And now I've got to factor this. And this is x squared, so I'm going to break it up into x and x. The last term is plus. So I'm looking for numbers that multiply to 36 and add to 15. Well, I think you can realize that that's 3 and 12. And they're both going to have to be minuses in order for this middle term to be minus, which will give me x minus 3 equal to 0, which gives me x equal to 3. I'm going over here. And over here, I'm going to have to do plus 12 to both sides, and that'll give me x equal 12. So I get as my two answers 3 and 12. But notice we still would have to do this check, because 3 and 12 just gives me possibilities A, B, or C. It could be 3 and 12, it could be just 3, it could be just 12. The only thing it excluded was choice D. And I still have to do the check, because when I have a radical equation, I must check. As we noticed, 3 did not work. Even though we did all the correct work and got at 3 and 12, we have to check to make sure we don't have what we call this extraneous root. Okay, I think we're pretty okay on radical equations. Again, if you're going to get it as a multiple choice question, like you will on your final, you can just, this is a good case where it just makes sense to just try the answers and see which work. Because you're going to have to try them anyhow. You're going to have to do a check. Now we're almost finished with chapter 6. which is a chapter on radicals. But we have one more section that's very important to do. And that is to go back to the original thing. Remember when we talked about something like this, when we had a square root, we said, if you only have real numbers, we can't do the square root of a negative number. Why? Because the only possibilities these numbers could be either 5 or -5. But 5 times 5 is +5, and -5 times -5 is also +5. There's no number that when you multiply it by itself will give you a negative answer. The answer will always be positive. That's if it's a real number. What are the real numbers? Well, all the numbers that we dealt with until today, all the numbers that are on the number line. Today, what we're going to do is we're going to do a exercise in logic. We're going to say, well, what happens if we could do the square root of a negative number? What would happen then? It turns out that we're going to introduce one new real number. That new number is going to be the square root of -1. In other words, we're going to talk about what would happen if we could actually do the square root of a negative number. Now, the square root of -1 has to be a number that we've never mentioned before, because it can't be a real numbers, and we've only dealt with real numbers. So we need a new symbol. The new symbol that we use for this new number is what's called I. And if you notice how I'm writing it, I'm not writing I like this. Why? Because I'm doing this on a board. I'm not typing this. And if you're not going to be, if I don't make that dot very, very clear, you might think it's just the number 1. And the square root of -1 is not 1. It's this new number I. So I will either write the I like this or like this. In other words, I'll make a script letter. I usually will use this symbol. I'm a little bit too lazy to do the extra piece there. But you'll be very clear that what we're talking about is I and not 1. Okay. So we have this new number. Let's see what happens when we start working with numbers that involve this new number. Well, let's first look at something like the square root of -25. We know from before that we can simplify radicals. Remember, this is a regular radical sign. And we know we can simplify radicals by breaking them up into 2 pieces. Well, what would happen if I broke this up into the square root of 25 and the square root of -1? Well, this 25 times -1 is -25. Now I can take the square root of the 25, which I know is just plain 5. And the square root of -1 is my new number, the one I just introduced, this new number. So the square root of -25 is 5i. Why do we use this letter I? Because this new set of numbers that we're talking about is sometimes called the set of imaginary numbers. Now notice, it's not a figment of my imagination. We really made, people do this. It's just called imaginary numbers because the numbers until now that we were talking about, all the numbers that we were talking about now, until now, have been called the real number system. So now we're going outside of the real number system. Well, if something's not real, what should we call it? So they said, let's call it imaginary. So these new numbers that we're talking about are called imaginary numbers. So the question is, how do we work with these imaginary numbers? Well, the algebra of working with imaginary numbers is just exactly like working with real numbers. All the rules that we've used till now will apply here as well. So let's say I had something like this, where I wanted to add the square root of -36 plus the square root of -49. Now, first of all, they're two radicals, they're two square roots. That means we can't add it unless we simplify them. And we can't work with square roots of negative numbers. We can work with i's, but we can't work with the square root of negative numbers. So the first thing I have to do is simplify each expression. Well, the square root of -36 is going to be the square root of 36 and the square root of -1. And the square root of 36 is 6. And the square root of -1, remember, I is the square root of, let's put this on top. I is the square root of -1. This is the important thing. It's not -1, it's the square root of -1. But whenever I see the square root of -1, I'm going to replace it with this new number I. This I'm going to break up into 49 and -1, which is going to give me 7i. And now I can add the 6i and the 7i. It's like adding like terms. They both have i's to them. My final answer is 39. So once I simplify them, then I add them just like regular algebraic expressions. They have to be like, and they have to be, you can, so that you can add them. Now, what if I have something like this? Suppose I have the square root of 9 plus the square root of -25. Okay, we've got to simplify them before we can add them. They're not like radicals. Well, this is easy to simplify. The square root of 9 is just plain 3 because it has no negative in it, and the square root of 9 is 3. The square root of -25 is going to be the square root of 25 times the square root of -1, which will give me 5i. Don't forget, when there's a negative inside a radical, it's going to translate to an I. And I cannot combine these any further because they're not like terms. As a matter of fact, we give a plain number like this is called an imaginary number, but a number that's a combination of a real number, 3 is a real number, an imaginary number is what we call a complex number, because it's a combination of two types of numbers, real and imaginary. Complex numbers are what we call, they're in the form of a plus bi. Whenever you're told to give your answer in a plus bi form, what it means is that you're going to look to get your answer with an I in it, but be careful not to add the I part to the non-I part. These two are, it's like 3 and 5x, you can't combine them. 3 plus 5i can't be combined. Your answer would be this number. This is a plus bi form. Okay, what if I gave you two complex numbers to add? What if I asked you to do 3 minus 7i, that complex number, plus 4 plus 11i. This is one complex number, it's a plus bi form. This is a number. How are you going to combine them? Well, just exactly the way you would do regular algebra. First of all, this is as if there's a plain regular one in front of each of them. We're going to remove those parentheses. Remember, if there's nothing in front of the parentheses, it's as if there's a 1 there. So multiplying this by 1 just leaves me 3 minus 7i. Multiplying this by 1 gives me 4 plus 11i. In other words, you could have just removed those parentheses. The only time you have to be really careful is if there's a minus in front of them. And now you're going to combine the like terms. So the 3 plus the 4, you can combine to 7, because they don't have any of them. And the negative 7i plus 11i is going to give you 4i. And here's your answer. It is an a plus bi form. It's a complex number. So combining, adding and subtracting numbers with I are not hard, just regular algebra. Let's go one step further. We have a little bit more time. So I want to go one step further, and I want to talk about what happens when we want to multiply numbers that have i's in them. So let's start with something really easy. Let's say I had the square root of negative 16, and I want to multiply by the square root of negative 9. Now remember, I'm multiplying. The first thing I have to do is know I cannot multiply square roots of negative numbers. I can't work with square roots of negative numbers. What I can do is convert them to i's and work with them in terms of i's. Well, I think you're going to realize this is square root of 16 times negative 1, which is 4i. And this is square root of 9 times square root of negative 1, which is 3i. In other words, the negative inside the radical sign converts to an I. So I do the square root of 16, which is 4, and that minus gives me I. If there's no negative, there's no I. Well, now, these are just regular imaginary numbers, so I can multiply them. So I'm going to do 4i times 3i, and this is regular algebra. 4 times 3 is 12. I times I is I squared. Just like we would expect. The only thing is, what does I squared mean? So let's go back to that. I squared means the square root of negative 1 times the square root of negative 1. You're multiplying the square root of negative 1 by itself. Well, what happens when you multiply a number in a radical by itself? What happens when you square a radical? I squared times I squared is going to be the square root of negative 1 times the square root of negative 1, which is just negative 1. Anytime you square something that's in a radical, you're basically just removing the radical. In other words, and here's the very most important thing that I'm telling you probably today, the value of I squared is negative 1. I is an imaginary number. It's the square root of a negative number. It's not real. But I squared, when you multiply by itself, you get plain -1, not in a square root sign. It's a real regular number, a regular real number. Which means that if I get 12i squared, what I'm really getting is 12 times -1. So my answer is -12. So when I multiply the square root of -16 times the square root of -9, I get the answer -12. So the big thing that we're going to always have to remember is going to be that when we're multiplying numbers that have i's, if it just ends up being I, fine, just leave it I. But if it ends up being I squared, replace the I squared by -1, because I squared can be simplified to an easier number, to the real number -1. Well, what if I had two complex numbers? I'm just going to do this, and this is where we're going to leave off and start on Friday. What if I had, let's say, the complex number 3 plus 5i times 2 minus 7. I have two complex numbers. Remember, a complex number is a combination of a real number and an imaginary number. Well, if you look at it, it looks like two binomials, and that's exactly what it is. So when you're going to want to multiply them, you're going to have to multiply them the same way you multiply binomials. In other words, you're going to have to use FOIL. So we'll do first 3 times 2, which will give me 6. Outer 3 times -7i. Remember, just think about these. Let's think those, what you would do if those i's were x's. You're okay. 3 times -7i is -21i. Inner 5i times 2 is plus 10i. And last, 5i times -7i is minus 35i squared. Don't forget that it's an I squared because you have an I times an I. Okay, remember that what I also told you. Anytime you see an I squared, you're going to replace that I squared by -1, because I squared is, you don't replace I, you leave your answer with I, but you do not leave an answer with an I squared, because I squared is the real number -1. So I'm going to take this -35 and multiply by -1, which will give me plus 35. And now I combine my like terms. The 6 and the 35 can be added. That will give me 41. The -21i plus the 10i can be combined. -21 and 10 gives me minus 11i. And I can't go any further. This is my answer. Notice it's an A plus. It doesn't matter when I say A plus BI form. The sign really means 41 plus -11i. So it's A plus BI form. You get a real part and an imaginary part. Okay, and this is where we're going to stop. We're going to continue with our discussion of imaginary numbers next time. Very important. So I will see you. I'm going to, does anybody have any questions before I end the session?